Hey everyone, I wanted to go over the 1.4 solving absolute value functions assignment. And so rather than working things out and going over problem by problem, I worked it out ahead of time, and then I'll just quickly explain to you what I did. So the first four are pretty simple. It's just take the absolute value of the number. It's an expression, okay? So what I did to show work was I took the absolute value of whatever was inside the absolute value. So the first one's -2 because there was a negative on the outside. The negative on the inside just turned it to 2, but the negative on the outside kept it at -2. So number 3, -3 times -2, do that first. Don't do -3 times, don't turn -3 into +3 or something, but anyway, you get absolute value of -6, that's going to be 6. And 2 and 4, well, absolute value of -7 and the absolute value of 7 are the same thing, so it says 7 minus 7, you get 0. And then -15 over 5 simplifies to get -3, and absolute value of -3 is +3. Okay, so let's talk about numbers 5 through 19. So you're going to have the positive and negative solution to every problem. Again, for more detailed explanation, look at my 1.4 video notes. So the absolute value of 5 and absolute value of -5 is 5. Okay, that's really all there is to that on number 5. Number 6, you can't take the absolute value of something won't equal a -7. Okay, the absolute value of 7 is 7. The absolute value of -7 is still 7. So you'll never get a negative value. Okay, that's why the answer is no solution. This one, -5p. So don't take the absolute value when you're solving it. See how you set it up? -5p equals 35, -5p equals -35. So that's where you take into account the absolute values when you're solving it. Like, so I don't write 5p equals 35 and 5p equals -35. Okay? By doing the positive and negative solutions, you're covering that base. You don't have to change anything on the inside of the absolute values when you're solving it. Okay? So anyway, dividing by -5 gets you -7 and 7. Number 8, a divided by 3, or a over 3. So the opposite of that would be multiply both sides by 3. So I get 12, and I get -12 because I equal it to -4. Number 9, b minus 2 equals 5. Again, I'm not going to change that -2 to a +2 or something like that because it's absolute value. That doesn't really make any sense because you're trying to figure out what you can plug in, and then when you do that math, it'll equal 5. Like 7 minus 2 equals 5. If I change that to +2, it'd say 7 plus 2, and that's 9. So that doesn't make any sense. And then so you go b minus 2 equals -5. So -5 plus 2 is -3. Okay, so that's where those are those two answers for number 9. Number 10, similar problem. K plus 6 equals 9. Set it equal to -9, so that won't equal to 9. Minus 6 each side, you get -15 for one answer, and you get 3 for the other answer. Number 11, a little bit extra work because you have a number by the letter now. So I set it equal to -13, and I set it equal to 13. I can add 3 to each side, and then I'll have to divide 8. So when I do that, I get a fraction for one of them, -5 over 4, and then I get +2 for the other one. Number 12, I get no solution. If there's something on the outside of the absolute value, take care of that first. So I -7 to the other side. When I did that, I saw it's going to equal -4. When you have the absolute value of something equals a negative, like only the absolute value stuff. See, I only have something on the inside of the absolute value bars. There's nothing on the outside, and it equals a negative, then you can conclude it's no solution, okay? So if there were other stuff on the outside and there was still negative, maybe by getting rid of it, adding or subtracting, dividing something, it'll turn it positive again. So don't jump to the conclusion that it's no solution unless you have only the absolute value of something equals a negative. Okay, let's move on to number 13. So number 13, you have two absolute value expressions are equal to one another. So make one side negative. So you see how I made one side negative on the other ones, but it's different with this one because you have two absolute value ones. But really it's the same process. So this side I made a -j. It doesn't matter what side you pick to be negative. this, there's just a j on the left-hand side of the equal sign, so that's what I did there. So anyway, minus 2j over, and I get negative j equals 3, so positive j equals negative 3. When I minus 2j over here, I get negative 3j equals 3. Dividing by negative 3, I get j equals negative 1. Looking at number 14, 3f minus 6 equals 9f, and then so I did 1 equaling to negative 9f. So I minus 3f to each side on each problem, and I got negative 12f equals negative 6 on the left, so I divided by negative 12, and I got positive 1 over 2. On the other one, when I minus 3f, I got positive 6x equals 6f equals negative 6, so dividing by 6, you get negative 1. Okay? Number 15. Now you have more than one term on each side. So up here, it was just a single letter, 9f. That's not a single letter, but it's like a single term still. So if that happens, make the entire side negative. Don't just change one number or letter. See, so I put it in parentheses, negative b plus 3 right there, okay? So it's important that you make one side entirely negative. So let's go over this one real quick. I got b plus 3 equals 2b minus 2, so I minus b to the other side. I get 3 equals b minus 2, so I added 2 to the other side, and I got b equals 5. On this one, when I distribute the negative, I got negative b, and then minus 3 equals 2b minus 2. So I added b this side, and I got 3b. And then when I add 2 over there, it's a negative 3 plus 2, so I get negative 1 equals 3b. So when I divide by 3, I get a fraction of negative 1 over 3. Number 16, similar thing. You have this 2 on the outside, and normally I'd say divide it if you can, but there's another absolute value expression over there. So don't divide it. You'll actually want to distribute it. But if it were a single number over here, not an absolute value thing, you would want to divide out the 2. But see how I made one a negative 2, and then this one is just kept as a regular positive 2. So this one is solving it as is, just without the absolute value side, and then this is my negative side when I'm doing it the second time. So on this one I get negative 2h minus 6. So I add 2h over, I get 6h. I add 2 over, I get negative 4. When I divide by 6, I get negative 2/3. Okay, on this one, when I distribute the 2, I get 2h plus 6. So I minus 2h over, and I get positive 2h minus 2 equals 6. So I added 2 over, and I got 8. 8 divided by 2 is 4. Okay, number 17 is a similar problem. You have a number on the outside of the absolute value. So I'm going to distribute it, but on one of them, I'll make it a negative 3, and I'll distribute that negative 3, and by doing that, I will have made that entire left side negative. So I got negative 3 plus 15, because 2 negatives multiply to get a positive. So I added 3w, I got 5w. I minus 10 over, I got 5. 5w equals 5, divide by 5, you get 1. This one, when you distribute the 3, you get 3w minus 15 equals 2w plus 10. So I minus 2w over, and I got w minus 15 equals 10. So I added 15 over, and I got 25. Number 18, I put a star by it because it has an extraneous solution. Okay, so I go over those a bit more in detail on the note videos, but you are likely going to, well, I don't know about likely, but you need to check to make sure you don't have an extraneous solution if you have a linear equation and an absolute value. So the graph of 2y plus 5, absolute value of that would make a v. The graph of 3y is going to make a line, and so it could be like that. All right, so that's intersecting one time. Now, every now and then, you could have a line intersecting 2 times, and you wouldn't have an extraneous solution. But on this one, I purposely put it so that there is an extraneous solution, so you have something like this, where it's only intersecting 1 time. So let's talk about that. So this first one is 2y plus 5 equals 3y. See, I just dropped the absolute value bars. It's positive. I didn't change any signs. I minus 2y over. I got 1y equals 5, so y equals 5. Okay, so that one's pretty normal. But this one, when you make it negative, you subtract 2y over it, and you get negative 5y equals 5. So when you divide by negative 5, you get y equals negative 1. And so that should raise an eyebrow because I got a negative number here. When I plug in a negative number here, 3 times negative 1, see I wrote it there, 3 times negative 1, that's going to equal negative 3. And then when I plug it in to the inside of the absolute value, I'm going to get negative 2 plus 5, and negative 2 plus 5 is positive 3. Okay, so what's happening here is I have the absolute value of positive 3 equals negative 3, and, you know, even if this was the absolute value of negative 3, the absolute value of negative 3 is still positive 3. So what you have is when you plug it back in, it's saying 3 equals negative 3, and that's not the case. 3 can only equal to 3, all right? So because you can't equal a negative from an absolute value, that solution wouldn't work. So you would say y equals negative 1 is an extraneous solution. So I just added that note there, and that's it. That's it for this video. I hope this helped. Again, for more detailed explanations of how to solve absolute value problems, check my 1.4 note videos. I believe there are 2. Okay, bye everyone.